Hello everyone, myself Sai Prasad, I lecture in AhleBait High School in the Junior College. Welcome to a series of the lectures of 9th class maths. We have started a discussion with the chapter that is areas. What did we learn in this chapter? We started with the basic theories, how do we find the areas, okay. Then by using different theorems of your previous chapters, and we learnt the midpoint theorem, right, and based on those we did more problems, right. Let us do few more problems of this chapter, shall we? See here. Here is the question. He is telling that P is a point in the interior of the parallelogram as shown in the figure. Okay, P is connected in some way, and they gave this kind of lines. There is no diagonal in between. Remember, show that area of triangle APB and triangle PCD. He is telling that the area of this and this, if I add these both, I should get the area which is exactly half of whole parallelogram. Okay. Now see here, let us do a little bit of construction. Okay, let us do a construction. What do we do is, let us draw a line parallel to AB and a line parallel to BC. Okay, let us write them as P, Q, M, N. Okay. Now see here, construction, draw, P is already there, right. Let us take it as Mn is already there, let us write it as S and T. Okay. Now see here, let us draw ST, SPT which is parallel to AB, and NPM, this is a straight line. Remember, even if I write 3 letters, it should be a straight line parallel to BC. Clear? Now let us check at the first question. What is given here? Triangle APB. If you observe here, APB is in between AB and ST, right. If you observe here, ASTB is a parallelogram, right, and here triangle APB and ASTB are in between same parallel lines and on same base. Okay, then I can tell that area of triangle APB is half of area of parallelogram ASTB. Isn't it clear? Similarly, we can write the second one, that is triangle PCD. Okay. Similarly, area of triangle PCD is half of area of this parallelogram SDCT. Okay. Let us add these both, 1, 2. If I add both, I will get area of triangle APB plus area of triangle PCD is equal to half of area of ASTB plus area of SDCT, right. Now tell me, what is ASTB plus STBCD? That is nothing but this half plus this half, completely it becomes area of ABCD parallelogram. Is it right? That is what they asked us to prove. Yes. Similarly, let us check with the second one. What did he give? Area of APD plus area of PBC, APD plus PBC, this plus this, okay, is equal to APB plus PCD. APB plus PCD is already half of ABCD, right. Similarly, we have to prove this plus this, okay. Just check here, again the same thing, triangle APD and parallelogram AM and D are on same base and between same parallel lines, then area of triangle APD is half of area of AM and D. Clear? Do you understand? That is, since this is half of this area, then we can directly tell that this plus this is equal to half of total ABCD. Therefore, area of triangle APD plus area of triangle PCB is half of, what is it? Area of ABCD, right. Now, just check, let us have this as 3 and this as 4. From 3 and 4, if you observe, this is equal to these two, okay. That is, area of triangle APB plus area of triangle PCD is equal to area of triangle PD, what is this? Area of triangle APD, right? APD plus area of triangle PCB. Clear? Did you understand? The only thing we have to remember, only one proof, that is the triangle and the parallelogram, if they are between two parallel lines, then the triangle will be the half of the whole parallelogram. Clear? Shall we move to the next problem? Let us do. Look at the next question here. Here, the one thing we have to remember from here is, we know that if there are two things, that is, if there is a parallelogram as well as a triangle between the two parallel lines and on the same base, we know that that triangle will be exactly half of that parallelogram. Similarly, one more thing is, if there are two triangles between the same parallel lines, okay, that too on same base. For example, if I say, if this is one triangle and this is one more triangle, let us say ABCD. If I say triangle ABC and triangle BCD, okay, they lie between two parallel lines and also they are on the same base, obviously their areas will be same. Clear? Based on that, let us do few problems. Okay, see here. Here he gave that in this figure, AP is parallel to BQ is parallel to CR. Then he is telling us to prove that triangle AQC is equal to triangle PBR. Okay, how do we prove? Are they between same parallel lines? No, right? If you observe here, AP and BQ are parallel to each other, then the triangle AQB and the triangle PBQ are on same base and between the two parallel lines. Therefore, we can consider these two triangles are equal. Clear? Now, see here. Let us consider parallelogram APBQ. Okay. In this parallelogram, if you observe, AP is parallel to BQ, right, and the triangles APB, and the triangles AQB and triangles PBQ. Okay, these are the two triangles which lie between same parallel lines, so they have equal area, that is, I can write it as triangle AQB is equal to triangle PBQ, right. Similarly, let us take this bottom quadrilateral, that is, in this BQCR, in this if we observe, BQ is parallel to CR, right. Then what are the two triangles here? Consider this triangle first, BCQ, okay. Triangle BCQ is equal to triangle BQR, okay. Now, let us add these both, okay. Add 1 and 2. What do we get? Triangle AQB plus triangle BCQ is equal to triangle PBQ plus triangle BQR. Clear? Now, just check it here, AQB plus BCQ, what is it? AQB plus BCQ, what is this? This is nothing but the whole triangle, that is triangle ACQ. Clear? Just add areas for everything, do not get confused. And if you observe here, PBQ, BQR, PBQ, BQR. This comes as PBR, that is equal to area of triangle PBR. Clear? That is what they asked us to prove, right? Yes. Don't get confused, you have to remember this statement. What is it? The triangles between two parallel lines, and if they lie on same base, their areas are equal. Clear? Shall we move on to the next problem? Let's do. Look at the next question here. He gave in a triangle, just look at the figure, A is a midpoint of a median AD. What is a median? A median is a line which touches a vertex to the midpoint of the opposite side, right? That is, D is a midpoint of BC, right? And here the median is AD. Fine. Then he is telling that E itself is a midpoint. Clear? The only thing you have to remember here is a median always divides a triangle into two equal halves. That is, the area of this half will be always equal to the area of this half, right? See here, let us consider a triangle ABC in which, given that AD is a median, right? Then obviously we know that the area of triangle ABD is equal to area of triangle ADC. Is it right? That is obviously half of area of ABC. Clear? Can you remember? Similarly, if you consider triangle ABD, let us consider triangle ABD and triangle ADC. Okay. Here BE is a median, okay. Here BE is a median and here EC is a median, right? Yes or no? Here if BE is a median, then obviously this whole triangle is divided into two parts, that is nothing but area of AEB, okay, triangle AEB, that is half of area of triangle ABD. Clear? Similarly, here also I can write it as area of triangle ACE is half of area of triangle, let us write ADC. Okay. Now, if you observe, ABD is nothing but ADC, okay, from this statement, then obviously this is equal to this, okay. From this one, from 1 I can write area of triangle AEB is equal to area of triangle ACE. That is what they asked us to prove. Yes, first one, clear? And not only that, area of triangle AB is half of area of triangle ABC. Clear? ABE is 1/4 of triangle ABC, don't just confused here, okay. If we observe here, we know that ABD is equal to ADC and that also equal to half of ABC, and if you observe here, AEB is half of ABD. Let us take from this statement, from 2 area of triangle AEB is equal to half of, what is ABD? Can I write ABD as half of ABC, right? That is half of area of triangle ABC. Half into half, that is 1/4 area of triangle ABC. Clear? That is what they asked us to prove. The only thing you have to remember in this problem is a median divides the whole triangle into two equal halves. Okay. Next, look at this question here. In the figure, DE are the points on the sides of AB and AC. Okay. Area of triangle such that triangle DBC area is equal to triangle BEC. Okay. What is the rule we know? The areas between two parallel lines of a triangles are always equal, right? Yes or no? The areas of a triangle between two parallel lines are always equal. He is telling that this area is equal to this area, right? What is given? Triangle DBC area is equal to area of triangle EBC, right? If you observe, both the triangle lie on same base, that is BC. Clear? And they have equal area and have equal area. Obviously, they lie between two parallel lines, that is nothing but BC is parallel to DE. Clear? That is what he asked us to prove. Is there anything extra? Right? Clear? Shall we move on to the next problem? Let's do. Look at the next question here. He is telling that in this figure, XY is a line parallel to BC, okay, is drawn through A. If BC is parallel to CA, if you observe here, this is BC is parallel to this CA, okay, this is BE, okay, BE is parallel to CA and CF is parallel to AB, are drawn to meet XY at the two different points, that is E and F. Then he is asking us to show that the area of this is equal to the area of this, okay, that is ABE is equal to ACF. Okay, did you understand? Now let us take two pairs of lines. Let us take BE parallel to CA. Okay, see here, BE is parallel to CA, fine, and there are two triangles here, that is triangle ABE, here triangle ABE and triangle ABC, okay, are on same base and between two parallel lines, isn't it? They are on the same base, that is we can consider it as AB as a base, okay, and they are between two parallel lines, that is BE and CA. Therefore, I can consider the areas of these both triangles are always equal, that is area of triangle ABE is equal to area of triangle ABC. Clear? Similarly, if I observe these two, similarly AB is parallel to CF, okay. From this I can write area of this AFC, triangle AFC is equal to area of triangle ABC. From this both I can tell that this is equal to this and this is equal to this. Therefore, area of triangle ABE is equal to area of triangle AFC. Clear? The only rule, what is it? The two triangles between two parallel lines and on the same base also have equal area. Okay. Look at the next question here. In this figure, A, B, C, D, E is a pentagon. A line through B, okay, parallel to DC meets at F, okay. Then he is asking us to prove that the area of ACB is equal to area of ACF, okay. He is telling that this whole line is parallel to this. Clear? Now just observe, ACB and ACF both lie on same base. Here given AB is parallel to CF, then I can write triangle ABC is equal to area of triangle ACF. Why? Because they lie on the same base, that is AC, and between two parallel lines AB and CF, okay. Since they lie on same base AC and lie between parallel lines AB and CF, okay. And the next second proof, what did they ask? Area of AEDF, just write it, area of AEDF, okay. AEDF, can I divide into AEDC, area of AEDC plus area of ACF, right? Yes or no? We also know that area of ACF is nothing but area of ABC. Yes, therefore I can write it as area of AEDC plus area of ABC. Okay, now just observe AEDC plus ABC, that is nothing but AEDC and B, therefore that is nothing but that is equal to area of A, B, C, D and E. Clear? Fine. The only thing we have to understand is few theorems and the few statements. Clear? Fine. By this problem we can end the chapter, that is areas. What did we learn in this chapter? We started with the basic theory of areas of basic triangles, parallelograms and all other quadrilaterals, right. Then we learnt about the quadrilaterals area, how do they differ, and the midpoint theorem. Then the areas between two parallel lines, that is if it is a triangle and parallelogram, then the triangle will be exactly half of the parallelogram. When it comes to the two triangles between two parallel lines on the same base, their areas will be always equal, and not only that, the areas of two congruent triangles is always equal. Clear? Fine. Hope everything is clear for you. Fine. This is for today. Let us meet in the next session with the new chapter of 9th class. Thank you.